The Mikoyan-Gurevich MiG-25, NATO codenamed Foxbat, is one of the fastest military aircraft to ever enter service. It is a twin-engined interceptor and reconnaissance plane and was the last aircraft that Mikhail Yosifovich Gurevich worked on before he retired. During the Cold War, the Soviet air defense forces were tasked with the difficult job of policing the vast expanse of Soviet airspace. This territory could be threatened by accidental border violations as well as subsonic nuclear-armed bombers like the B-47 Stratojet and B-52 Stratofortress. Also concerning were the very high altitude, secretive overflights conducted by the U-2 reconnaissance aircraft in the late 1950s and early 1960s that could operate with a degree of impunity. Perhaps more worrying for the Soviets was the emergence of supersonic American bombers such as the Convair B-58 Hustler in 1960 that could deliver a single nuclear weapon and travel at speeds in excess of Mach 2. The North American B-70 Valkyrie was also on the drawing board at this time, a prototype strategic bomber capable of cruising at 70,000 feet at speeds in excess of Mach 3. These developments in American bomber technology led to the conception and planning of the MiG-25. The Mikoyan-Gurevich Experimental Design Bureau began work on what would become the MiG-25 in 1959, exploring a range of engine layouts. One design had the engines stacked vertically like the English Electric Lightning, a plane that we have covered previously on this channel. However, the favoured design opted for a traditional side-by-side configuration to lower the vertical profile of the aircraft and enable easier maintenance. The first prototype reconnaissance variant made its maiden flight on the 6th of March 1964, and the Interceptor variant followed on the 9th of September of that year. Given the major technological challenges that were posed by the design of the MiG-25 with respect to metallurgy, engineering and aerodynamics, full development would not be completed for several years to come. The choice of materials for the MiG-25 posed a problem for the designers, as the thermal stresses endured at speeds in excess of Mach 2 are very severe. Titanium was the optimal choice, but it was expensive and hard to work with. In the end, heat-resistant E2 plexiglass was used for the canopy, and the wings and fuselage were constructed from stainless steel. As with the famed SR-71 pilots, the MiG-25 pilots would be required to wear fully pressurized spacesuits for their own safety, given the high speed and altitude environment. The airframe was built around its massive twin Tumansky R-15 afterburning turbojet engines. These axial flow single-shaft engines were devised at the OKB Design Bureau in the late 1950s and were originally intended as the power plant for the Tupolev Tu-121 high-altitude, high-speed cruise missile. They provided a maximum thrust of 7,500 kg-feet or 16,500 pound-feet when dry, and 11,200 kg-feet or 24,700 pound-feet of thrust when afterburning. This power is what enabled the MiG-25 to theoretically reach a maximum speed of Mach 3.2, although this was limited to Mach 2.83 to prevent overspeed and permanent damage to the engines. Indeed, this power came at a price, with each engine possessing a service life of only 150 hours. The MiG-25 can attain a maximum altitude of 89,000 feet with a rate of climb of 208 meters per second or 40,900 feet per minute, and its time to altitude of 20,000 meters is 8 minutes 54 seconds. It also has a range of 1,160 miles at Mach 0.9 and 1,013 miles at Mach 2.35. The lack of real discrepancy in range between subsonic and supersonic speeds is due to the extremely low pressure ratio in the engines at subsonic speed. The Interceptor variant was initially fitted with the TL-25 Smerch A radar NATO named Foxfire, a powerful and long-range system that was resistant to jamming but lacked look-down shoot-down capability. This was a problem because by the late 1960s the high-altitude, high-speed strategic bombing doctrine had shifted to one of low-level penetration of air defences due in part to the introduction of highly effective anti-aircraft missiles and the use of ICBMs as the cornerstone of the US nuclear arsenal. This shortcoming limited the radar's effectiveness against low-flying targets. In its interceptor configuration, the MiG-25 was armed with 4 R-40T air-to-air missiles. These were the largest missiles ever to go into production for air-to-air equipment, and were equipped with a thermal homing warhead. It could also carry the R-40P, that had a semi-active radar-guided warhead. These missiles could engage targets some 50 miles away. From a technical perspective, it became readily apparent to the Design Bureau that the MiG-25 had the potential to break a number of performance records in altitude, speed, and time to height. It was revealed to the public for the first time in 1967 at the Domodedovo Air Show, where 4 prototypes made their appearance in a flypast, and the aircraft entered full-scale production in 1969. The Western response to the MiG-25 was one of great fear and apprehension. When recon photographs revealed its large wings and massive engines, the Americans believed it to be a highly maneuverable fighter, and this perspective informed the development of the highly successful McDonnell-Douglas F-15 Eagle. It was not until the defection of Soviet pilot Lieutenant Viktor Belenko to the West on the 6th of September 1976 that the capabilities of the MiG-25 were more readily understood. Lieutenant Belenko, dissatisfied with the communist system, took off in his MiG-25P near Vladivostok in the far east of the Soviet Union, initially following a flight plan for a training exercise. He then descended rapidly and headed out to sea, eventually landing at Hakodate Airport in southern Hokkaido, Japan, low on fuel and nearly hitting a Boeing 727 on touchdown. Lieutenant Belenko would seek political asylum in the US, offering to demonstrate his aircraft and go through the training manual that he had with him. The Americans were unable to take the MiG-25 out of Japan due to Soviet pressure on the Japanese to return it. However, Japanese and American technicians were able to disassemble it and analyze it in great detail. It transpired that the initial fears of the West about a Soviet superfighter were largely unfounded. Although Lieutenant Belenko's aircraft was at the cutting edge of Soviet technology, it was revealed that the aircraft's weight necessitated its huge wings, and it was essentially built around its massive engines. The assumption that it was constructed from titanium was also proved false. The radar was very powerful, around 600 kilowatts, and most of the onboard avionics were based on vacuum tubes, a dated technology, but it was largely in keeping with the Soviet tendency towards robustness. After 67 days, it was eventually packed up into boxes and returned to the Soviets in pieces, which were then reassembled. This aircraft is now on display in the Sokol plant in Nizhny Novgorod. In the aftermath of his defection, Belenko would be extensively debriefed by the CIA and US military, before moving to America, learning English and adapting to life in the country. He was granted asylum by President Gerald Ford and a trust fund set up that would provide him with a comfortable living in later years. After obtaining US citizenship in 1980, he would eventually become a consultant to the US military and aerospace industry, a public speaker and a businessman. After Lieutenant Belenko's defection, improvements were made. A pulse Doppler radar was added, the Sapphire 25, to an advanced version called the MiG-25 PD or Foxbat E. Further developments would be considered, but did not enter production due to the emergence of its successor, the MiG-31 Foxhound, an aircraft that we will cover in detail later on this channel. The MiG-25's production run ended in 1984 after 1,186 aircraft were completed, and the Gorky Aircraft Factory switched production to the MiG-31. It is still in limited service around the world, with the Algerian, Libyan and Syrian air forces. Previous operators include nations of the former Eastern Bloc, including Armenia, Belarus, Kazakhstan, Georgia, Turkmenistan and Ukraine, as well as India and Iraq. In terms of military deployments and operational history, the MiG-25 was used as a recon aircraft in Egypt to spy on Israel in the early 1970s, and would be used in a similar capacity in the Yom Kippur War, albeit operated by the Soviet 63rd Independent Air Detachment. The Interceptor version would often be tracked by Swedish Air Force radar over the Baltic Sea, making intercepts at 63,000 feet and 1.8 miles behind the SR-71 Blackbird at 72,000 feet in the 1980s. Elsewhere, the aircraft saw service in the Iraqi Air Force during the Iran-Iraq War, from 1980 to 1988. The Iraqis claimed that their MiG-25 shot down 15 Iranian aircraft, while losing only one of their own in air combat. Their most successful pilot, Colonel Mohammad Rayan, is credited with 10 of these kills. He would be shot down himself by Iranian F-14 Tomcats in 1986. He is still the most decorated MiG-25 pilot in history. The aircraft also saw combat in the Persian Gulf, shooting down a US Navy F-A-18 Hornet on the first night of the conflict, using an R-40 missile. After the war in December 1992, an Iraqi MiG-25 that violated the no-fly zone in southern Iraq was the first victim of the AIM-120 AMRAAM missile, and the first ever kill of the US F-16D Fighting Falcon that launched it. In the hands of the Indian Air Force, the MiG-25 was used as a reconnaissance platform in flights over neighbouring Pakistan. In May 1997, a MiG-25 RB exceeded Mach 3 over Pakistani airspace while flying at 65,000 feet. The resulting sonic boom blew the cover of the operation, and it was alleged by the government of Pakistan that this was a stunt to remind the Pakistan Air Force that they did not possess an aircraft that could successfully challenge the MiG-25's cruising altitude. The MiG-25 is regarded as an undoubted symbol of the Cold War, a time of great political turmoil and tension. At the time of recording, it remains the fastest manned serially produced aircraft in operational use anywhere in the world. Its legacy as one of the highest flying and fastest aircraft ever produced is well assured. Thanks for watching. Don't forget to subscribe to the channel to stay up to date with my latest videos, and I'll see you in the next episode of Scorch the Sky.